Hello everyone, so today we're going to have a look at factor pairs. So having a think about different arrays, different representations of multiplications. So Alex has made some arrays using these counters. So he's made some different arrays for the number 18. What calculation has been represented in each array? So look at that first one with the red counters. He's got one row of 18 counters. So he's got one row of 18 counters to make his 18. So look here, what's he done to make his 18 counters here? So this time he's got two rows of 9. That makes his 18 counters. What's he done here with his yellow counters? So he's got 3 rows of 6 counters to make his 18. So if we were going to find out what the factor pairs of 18 were, they are 1 and 18, 2 and 9, and 3 and 6. So factor pairs are the two numbers you can multiply together to get the number that you want to find the factor pairs of. So to be a factor pair of 18, 1 and 18, because they multiply together to make 18. A different factor pair for 18 is 2 and 9, because they multiply together to be 18. And a different factor pair for 18 is 3 and 6, because they multiply together to make 18. So 18 has 6 numbers, 6 factors, or 3 factor pairs if we look at them in pairs. Okay, let's have a look at it again. So let's have a look at the number 12 to begin with. I'll just move up here. So this one, number 12. So I've drawn the different array. So can you work out what I've done here? How many rows and how many in each row? So I've got 4 rows with 3 in each row to make my 12 counters. So a factor pair of 12 is 4 and 3, because 4 times 3 makes 12. What else could I do to make 12? Well, I could lay them out like this. I could lay them out 2 multiplied by 6. So there's another factor pair for 12, 2 and 6. What's this one? Well, there's just one row of 12. So the factor pairs of 12 are 1 and 12, 2 and 6, and 4 and 3. Right, let's have a look at it with 24 now. So I've shown you all the different ways I can lay out my 24 counters. I could have one row of 24, so that's first factor pairs of 20 for 24. I could have 2 rows of 12, so that's another factor pair. I could have 4 rows of 6, 4 times 6, or I could have 8 rows of 3. So 24's got more factor pairs than 12, because it's actually got 4 pairs. It's got 1 and 24, it's got 2 and 12, it's got 4 and 6, and it's got 3 and 8. Okay, so you're going to have a go now using these factor bugs for the numbers 45 and 64. So think carefully, what numbers can you multiply together to make 45? Well, I've given you the easiest one here. You can multiply 1 and 45 together to make 45. So that's one factor pair. Can you find another factor pair, two numbers that go together to make 45 when you multiply, and a different factor pair here? And then when you've had a go at that one, can you find the factor pairs for 64? I've given you that one. You've got to find another pair. And I've given you part of the pair here, so what goes with 4. And then I wonder what's going on here with this one. Who'll work that one out? Right, so see if you can pause the video while you find all the multiplication calculations which make 45. See if you can find the factor pairs of 45 and the factor pairs of 64. Okay, let's have a look then. So 45 can be made from 3 and 15, 3 times 15, or it could be made from 5 multiplied by 9. So here are all the factor pairs for 45. So 45 has 6 factors, or 3 factor pairs if we pair them up. Okay, let's have a look at the 64 one. So we know 1 and 64, 2 and 32, 4 and 16. And let's see who's worked out why this one was like a little tail on the ladybird. Because 8 times 8 is 64. But of course that's the same number, so it doesn't have a partner. It just has to stay on its own, 8. So 64 actually has 7 factors. 3 of them are in pairs, and then 1 of those is on its own because 8 times 8 is 64. That's just the same number twice. Okay, so time to find out if these are true or false. 8 and 2 are factors of 10. 5 and 50 are both factors of 50. 25 only has 3 factors. All the factors of 15 are odd. So get yourself some paper, see if you can work out these and whether they're true or false. Okay, let's find out. 8 and 2 are both factors of 10. That is false. 8 is not a factor of 10. Can't count in 8 to get to 10. 5 and 50 are both factors of 50. Let's have a look. That's true. 5 goes into 50 equally, and 50, of course, goes into 50 equally, so it's a factor. 25 only has 3 factors. Let's see. That is true. It has 1 and 25, and then it has 5 times 5, but that's 1 factor on its own, so it does only have 3 factors. 1, 25, and 5. All the factors of 15 are odd. Let's see. That is true. 1 and 15, they're both odd numbers. 5 and 3, they're both odd numbers too, so that was true. Okay, let's see what Dexter says. The bigger the number, the more factor pairs it has. Can you prove that Dexter is wrong? Pause the video while you have a go. Okay, so let's see how I prove Dexter to be wrong. 19 is a bigger number than 8. The factor pairs for 19 are only 1 and 19. Nothing else goes into 19 except 1 and 19. So it only has 1 factor pair, 2 factors. But 8 has the factor pairs 1 and 2 and 4 and 8. It has 4 factors. So that's how I've proved Dexter to be wrong. You might have had a different example of a bigger number only having a couple of factors and then a small number having quite a lot. Okay, Tommy is finding factors of 12 and 18. 12 and 18 have the same number of factor pairs. Is he correct? Explain your answer. So pause the video while you work that out. Okay, let's see if he is. So 12 and 18 have the same number of factor pairs. So what I did is I started with 12. Right, let me work out the factor pairs for 12. Well, I know there's 1 and 12. I know there's 2 and 6. And I know there's 3 and 4. So 12 has 6 factors, 3 factor pairs. Then I did the same with 18. So here's 18. It has 1 and 18. It has 2 and 9. And it has 3 and 6. So it has 6 factors, 3 pairs. So they both have the same number of factor pairs. So is Tommy correct? Yes, he is. They both have the same number of factor pairs. Look, I've proved it there at the side. And your little challenge, can you find two other numbers with the same number of factor pairs? Quite a few different choices there, so see how you get on with that. Okay, Class B is having a sports day. There are 36 children in the class. The children need to be in equal groups. What group sizes are possible? Pause the video while you have a little think about this one. Okay, let's see then what's possible. So you could have one group of 36. You could have two groups of 18. You could have three groups of 12, or you could have four groups of 9. So all the different group sizes possible are ones, but that's not really a group. 36s, one big group of 36. Groups of 2, groups of 18, groups of 3, groups of 12, groups of 4, or groups of 9. Now, given that it's a sports day, I think it's probably likely they would have groups of 3 or 4 or 9, most sensible size groups for a sports day, but they could have any of those size groups to make that work. Okay, so that's all for today on factor pairs. Keep working really hard, everybody, and I will see you soon for some more maths learning. Bye for now.